What observations can you make about A and B's points? Because see, I could pick this point right here, but what is different about this point versus A and B's? I'm talking really basic here, like a kindergartner plotting points. What is the difference between A and B and this one right here? They're all on the line, even the one here. But what else? Exactly. They're in the corner of the box. There's no half or percentage. Now, somebody said, Miss Blanchard, are we going to have to work with that? Yes, that's why we'll have a mathematical formula to help us. But right now, we're talking basic counting. So we want to pick, some teachers call them pretty points. When they told me that, I went, "Bleh! That's not even math sounding, right?" But you know why they call them pretty points? Because they're right in the perfect little space of the corner of the box. Okay? So they've given us 2 pretty points. I am going to warn you, you're not going to be given points. You're going to have to pick them at some point. So it's important that you know what a good point looks like. All right, that's phase 1. The second thing is, how can we determine which one's steeper, right? Visually look at it. Which one do you think's steeper? And don't say it out loud yet. I want you to stop, look at the line, think about what you know. Now, choose which one you think is steeper. Who thinks A? Oh, wait, he put his hand back down because nobody raised it. Who thinks B? Put your hand up. All right, so B is correct. Good job, Jacory. So, Jacory, I want you to pay attention to why Kale, and I'm picking Kale because I'm tagging back to what he did before. Why, Kale, did you pick graph B as the steeper one?
Because
it is closer to 90 degree angle. So we're going to use steepness benchmarks is what we're going to call them. And we're going to call them 90 degrees and 0 degrees. Because that's going to tell us that this is steeper and this is flatter. You're like, wow, Miss Blanchard, I can just look at the pictures and tell you which one's steeper. But what happens if I give you 2 graphs and they look like this? And they're only 1 degree apart. Can you tell which one's steeper? No. So it's important that we know how to measure it. Because we have to have a visible amount to tell which one's steeper. This is obvious, right? This is Mount Everest. This is Super Mario. Okay? All right. So we're going to say graph B is steeper. Here's my next question for you. Look at A and B again. Can we mark a path of directions to get from letter A to letter B precisely? So what I mean by that is, can we mark a path from here to here by counting boxes? So there's a half, there's a, I don't know, a 0.27 maybe. This is a 1/4 maybe. Is that accurate? No. So I can't just count across. Is there a way, by using pretty points, today's the only day I'll use that word, to count the boxes to effectively make a mapped path from A to B? Any ideas? Think gaming. How you might do it on a game, an old school game on a computer system. Think Pac-Man, how you move Pac-Man. How would you do it? Could I move up 2 and over 3? Could I? So effectively, I rose 2 and ran 3. So when we're talking steepness, we're talking how much did I rise over how much I ran. Now, I want to be clear. If I'm talking rising, I'm talking counting up or down. And if I'm talking running, I'm talking right or left, okay? So use that. Rise over run is just like that quick little word usage that to remind us of the math we have to do. So did we just measure how steep this line was with a numerical amount? The rise was 2, the run was 3. Anybody recognize that? What is it? A fraction. This is slope. Now let me ask you this question. What if I pick 2 different pretty points? What if I pick this one and this one? And I wanted to measure the slope. So I counted up 6 and right 9. And I got 6 over 9 for those points. Notice anything? They're equivalent fractions. So what does that tell us about the 2 slopes? They're equal. Why are they equal? They're on the same line. They're constant. So it doesn't matter which 2 points you pick, whether it's a bigger fraction or a smaller fraction, they're equivalent if they're on the same line. They are your constant. So if I want to assign slope a variable to represent it, which variable could I use if it's the constant? M. Because remember, we left K in the dust. So here's our M. So for this one, M is 2/3. And I am going to tell you, it is proper algebra to reduce your slope. Because it's a fraction, so you should always reduce it. Okay? Look at graph B. So let's map it out. Up 4 over 3. What's my slope? 4 over 3. Uh-oh. What kind of fraction is that? Y'all's favorite. And you can't do anything about it. You're stuck with the rise over run being 4 over 3. Is it simplified? Yes. Yes, it is. Now, I've got 2 slopes. Can I use those slopes to prove which one is steeper? Yes. How? They have the same magnitude, so which one's greater? Yeah. And it doesn't even matter about the denominators. You can change them both to decimals and pick which one's greater. So does that prove that this one's steeper? Yes, it does. Now, here's my other question for you. If I take this 4/3 and I do divide it, and I get 1.3 repeating as my slope, is that correct? Yes. What is that I just did? Anybody? Look at the second learning target. It's unit rate. You can simplify it to unit rate. Guys, this is what we did last week when we were finding the constant. You were really finding the slope and didn't know it. So now we're just applying it to a graph to where we can pull out that slope as we need it. You already know how to pull it out of a word problem. I just didn't call it that. So now we know that the variable M represents slope. We know that we can count boxes using 2 pretty points. By the way, this is called the staircase method. Why do you think? Looks like stairs going up, right? And technically, you could do this and keep counting, and the slope should be the same because it's a constant. Turn the page. Okay, let's do this model. So, which one visually looks steeper? A is steeper because closer to 90 degrees. B is flatter because closer to 0 degrees. Very good. So now which staff is greater? We're going to steeper. We're going to say A, but we're going to prove it by getting our slope. Right now, compute the slope of both. I'll get it. Y'all keep going. Make sure you write it as M equals what the slope is. M equals what the slope is. Look up when you're done and make sure it matches mine. Make sure that you've labeled your slope units in the triangle and as your fractions. And by the way, if it doesn't look like a triangle when you draw it, you probably did something wrong.